Uh, we have discussed some basic concepts of this heat. One more time, different scales we have in the temperature here. For measuring the temperature, okay, for measuring the temperature, we have different scales, okay, temperature. For measuring temperature, we have different scales. One is degrees Celsius, degrees Fahrenheit, Kelvin, Rankine scale, so Rumer scale, Rankine scale, and faulty thermometer. Different scales we have, right? In different scales, every scale will have some lower fixed points and upper fixed points. What are lower fixed points? In sense, lower fixed points is, what are the lower fixed points? Lower fixed points are nothing but I can say the melting point of water, and upper fixed point is nothing but the boiling point of water. It is 0 degrees in this Celsius, whereas here it is 100 degrees, and coming to here 32 degrees Fahrenheit, and here it is 212 here, whereas coming here it is 273 degrees, and whereas here it is 373 whereas here this is 0 and this is 80, and whereas this is it is around 492, and whereas this is here in this case 672, and faulty X I'm taking, here I'm taking as Z, correct? So these are the basic things for getting the relation between the different physical quantities in for measuring the temperature here, means for conversion one system of units in the system. From that information, we have derived one relation, that is C minus 0 by, means nothing but C by 100 is equal to F minus 32 by 9, F minus 32 by 180, and next what is this, K minus 273 by 100, and next we have here one more, it is R minus R by 80 we will get, and next one is RK minus 273, sorry here, not 273, this is RK minus 492 by 180 is equal to general scale here, Y minus X by Z minus X, Y minus Z by, okay, Z minus X, correct? Z minus X. Yeah, fine. Listen here, everyone. Good afternoon, good afternoon, good afternoon, good afternoon. Okay, fine. So these are the scales which we'll have. Fine. C by 100. I can write this relation. What is the use of this? Means we can convert the different scales. If you know the temperature in one scale, degrees Celsius, you can find in degrees Fahrenheit, or you can find, if you know the degrees Fahrenheit, you can find in kelvins, or any general scales here. Okay, yesterday we have seen some examples, sir, in the last class video. Some examples we have seen, conversions of the 1 degree Celsius to Fahrenheit or 400 degrees Celsius like this, right? And now let us see. Let us see some more examples here. Yesterday we have seen some more also. Let's consider, I measured this some temperature I got as one more time I'll tell you. The body temperature which I measured in degrees Fahrenheit is, let's consider I got the 120 degrees Fahrenheit. How much, Amma? 122 degrees Fahrenheit. How much? 122 degrees Fahrenheit. Okay, now. So 122. 1 second here. Yeah. Yeah. Then what is the C value? At 122 degrees Celsius, if I calculate the C value, what is actually C value? How much I'll get? Check it here once. C by, I can get right here 5. F is 122. Minus 32 by 9, I can write it, correct? Just cross multiply. 9C is equal to 122 minus 32. 122 minus 32, how much here? It's around 92, correct? 92, na? 92 into 5 into 5. I'll do one thing, okay, let it be. C is equal to how much I'll get, 92 into 5 by, 92 into 5 by 9. For easy calculation, what I am doing is, instead of taking this, I am taking this one as 120 degrees Fahrenheit. How much? 120 degree Fahrenheit. Then I will get this one as 120. 120 minus 92. Sorry, 120 minus 32. 120 minus 32. Yeah, sorry here. 122 degrees Fahrenheit 122 minus 32. Yeah, fine. 122 minus 32, it comes around 90. Easy calculation only we are getting here. Okay, na? 90. So it goes around 50 degrees Celsius. 50 degrees Celsius. C is 50 degrees Celsius. See how much I got here? 50 degrees Celsius, right? Yeah, it's fine. Now let's imagine that actually the correct value is 50 degrees for 125 degrees Fahrenheit. Okay, 125 degrees Fahrenheit. 122 degrees Fahrenheit is equal to, a student measured it one as a 51 degrees Celsius. He was saying it as a 51 degrees Celsius. Okay, na? 51 degrees Celsius. In this, okay, 51 degrees Celsius. In this, what I am doing here is, what is the error in measurement of the student? Okay, a student measured, converted 122 degrees Fahrenheit into 50 degrees Celsius. What the answer he got is around 51 degrees Celsius. Means 51 degrees Celsius is a wrong answer here. Then the question here is, what is the error? It may wrong or 0, no problem here. Okay, na? It may be 0. Means as we calculated C by 5 is equal to F minus 32 by 9. We know the relation here. So just simply write here 122 minus 32 by 9 and simplify here. C is equal to, we'll get as 50 degrees Celsius. How much will get, Amma? 60 degrees Celsius. Correct? 12 minus 3. 12 minus 3 will get as 90. 90 by 9, 10, 50. 50 is the answer. Actually, the value is, correct value is that one. Means this is the true value. We say it as a true value, correct value. But the student got the value as 51 degrees Celsius. Means what is the error here? 51 degrees is measured value and the correct value is 50. And the difference between these two is 1. Difference between these two values, measured value and the correct value is 1. 1 is the error. 1 is the error. Either this is a positive error or negative error. How can we confirm? The measured value is more than the correct value. Measured value is more than the correct value. When measured value is more than the correct value, then I can say simply that the error is positive. Correct? Error is positive. So for getting the correct value, what we have to do? We have to decrease. Means the student measured the value as 51. He got the more value. So the error is positive. Got it here? Error is positive. Error is positive means correction what? Listen carefully here. Correction -1. Then we'll get the correct value. Correct? This is correction. Okay. Positive error in sense, you will get the correction as negative. Got it here? Okay, na? I'll tell you one more time. Listen yet carefully. One more time. Lots time. Okay? Just listen carefully. Very easy, small topics. Let us see once. Okay? Actually, correct value is 70. Let's imagine. A student measured this one. He got the answer as 71. Then I can simply say the difference. This is a positive error. For getting the correct value from the measured value, he had to remove the error. Correct? Correct? The difference between these two is nothing but 1 amma. He was getting, this is measured value. This is true value. This is true value, measured value and the true value. Measured value is more than the true value, means the error is positive. When the error is positive, for getting the correction, what we have to do? Minus. Measured value is 71. How can you get the 70? Subtract it. So this is a correction is negative. Maybe some situations, some students may get it. The correct value is 20, but the value he got as 18. Means the measured value is less than, see, measured value, measured value is less than the correct value or true value. Okay, correct value or true value. True value is this much. Okay, then what is the meaning of that? This is a negative error. What is it? Negative error. Negative error. For getting the correct value, what we have to do? He has to add it. Understood here? He has to add it. Add it. Positive. Plus we have to do it. Okay, na? Negative error means we have to add here for getting the correct value. Positive error means we have to subtract. We have to subtract. Okay, na? These are the small concepts which we'll have in our, after just entering into the first year. Okay, just entering into the first year. Okay, in one of the track heat here. Okay, now let us see. In the same concept, I'll try to explain how to draw the graphs here. Why? Because graphs also some part which will have some part of the physics is occupied. Even in electricity we'll get here, in modern physics we'll have, whereas in heat we'll have, in mechanics also we'll get here. Graphs. How to draw, how to identify a graph, how to draw a graph. Got it here? Understood here? So we can say here how to confirm this graph here. You're taking the graph, let's consider. See, what I am doing here is simply what the relation I know here. The relation which I know here, degrees Celsius and Fahrenheit, C by 5 is equal to F minus 32 by 9. F minus 32 by, try to understand very clearly. After understanding, just if you practice it, it is very easy for you, okay? Fine. C by 5 is equal to F minus 32 by 9. Just they are asking us to draw a graph between the C, degrees Celsius and degrees Fahrenheit. How the graph is? Simple question. How the graph is? Okay, now once if you practice this, you can draw the graph between any two different scales also easily. This is cross multiply one summa. 9C is equal to 5F minus 160, correct na? 5C, 532 is 160, correct na? This is the relation which I am getting, right now. So actually, if you see this one, this is like y is equal to mx plus c. Bring this left side, I'll write like this. Can I write like this? 5F is equal to the 9C plus 160. 9C plus 160, correct? 9C plus 160 here, correct? Now how can I draw the graph here? Simply between the F and C. See, this is like a y is equal to mx plus c. Okay, anyway, I will write like this. One more step, let us take it. One more step. F is equal to, take this 5 right side. 9 by 5c plus, how much you will get? 8, yeah? No. How much you will get? 32. Okay, na? So this is the graph. See, if you observe here, this is like y is equal to mx plus c. Y is equal to mx plus c is a graph of a straight line, means equation of a straight line. Okay, if you draw the graph between these f and c, it must be a straight line. Confirm it. Understood here? Either a curve or straight line, how ellipse, a parabola, how can we confirm this? From this expression, we have to generally obtain expression for these two physical quantities between what you are drawing here. Okay, na? One more time, let's try it. Means my target is to the graph between the degrees Celsius and Fahrenheit. Degrees Celsius and Fahrenheit, right? So degrees Celsius and Fahrenheit, I have to draw a graph here. So before drawing the graph, what the relation I know it, just rearrange it here, cross multiplied and simplified, and I converted the expression like this. If you see this equation is like a straight line equation, y is equal to mx plus c. Means y on the y-axis f. On the y-axis f I am taking here. On the x-axis I am taking the c. On the x-axis I am taking the c. Okay. On the x-axis I am taking the cm. So this is right. This is positive y-axis. Everyone knows, I think so. This is negative y-axis and this is positive x-axis. This is negative x-axis. I am taking on the x-axis I am taking the x here, c. Means degrees Celsius. On the y-axis I am taking f here, degrees Fahrenheit. Okay, na? Degrees Fahrenheit. Understood here? So now if you observe in this situation, in this case, now my task is to draw the graph between these two. By seeing this, I can confirm that it is a straight line. Why? Because this is a straight line equation. Circle equation I have remembered. Circle equation will be like this. X square plus y square is equal to r square. Okay? Like this, we have some equations, sir. We will see in the further videos, okay? Further classes, right? Fine. Let's take it here. Y is equal to mx plus c. Now just draw it here. My task is here, I'll take in this expression, write c is equal to 0. Write c is equal to 0. What you will get, f is equal to 32. You are getting positive value or negative value? Positive value. Means f is positive when c is 0. C is 0 means here, f is plus 32 means here is the graph. I am getting the point. This is 32. Correct? Right here. In the place of just in this expression and in the place of c, just write y. X is equal to 0. You will get y intercept. Y is equal to y intercept. You are getting as how much? 32. Correct? So this is the graph. 1 point. Next, in the second situation, the second step, what you will write is just in the place of y, f, write 0. In the place of f write 0. What you'll get? Can you tell me? 9 by 5 is equal, 9 by 5 into c is equal to minus 32. Correct enough? And now c is equal, tell me one sir, minus 160 by 9. Correct ma? Minus 160 by 9. If you want to simplify or else keep it like this. What happened? No problem. Just our idea is to get the graph. Okay, fine. Just f is equal to 0. See, f is 0 here. On the x-axis, f is 0. Correct na? Minus, I am getting c value as minus. This is positive axis, this is negative axis. Minus 1.6. Sorry, minus 160 by 9. Correct na? So these are the two intercepts here. These are the two intercepts. Among these means which is a straight line here. It's a straight line means simply join these two lines. That's all. Over. This is a graph drawn between the f and c. Understood here? This is the way of practicing the graphs here. Okay. One more time. I'll try to repeat it once. Okay. See, first of all, what we have to do is, in this way you have to practice it, then we'll get the full graph. Means my task is to draw the graph between C and F. I'm taking the F here and I'm taking the C here. Some students will ask here, sir, is it compulsory I have to take F on y-axis only? If you want, take it or else leave it. What happened? If you want to take F here, take it. If you want to take C here, take it. No problem. No. You can take like this also. You can try like this also. No problem. Okay. But what the relation I know between the degrees Celsius and Fahrenheit is F minus 32 by 9. Okay. Just what I am saying here is C. Take it to left side. Okay. Or right here. 9 by 5. 9 by 5 is equal to how much I am getting here? F minus 32. Correct? F minus 32. From here F is equal to how much you are getting, Amma? 9C by 5 plus 32. Correct? 9C by 5 plus 32. Right? Correct? Na? Fine. Now in this situation, we have to draw a graph between C and F. Between C and F here. I am getting some messages here. Negative error. Okay, good. Right here. Fine. So this is the graph. This is like a y is equal to mx plus c. 1 second. I will do one thing. Just I will write it like this. F is equal to, okay, 9 by 5 into c plus 32. Correct? Na? Okay? Na? 9. This is m x plus constant. This is constant. Y is equal to mx plus c. Mx plus c is a constant. Correct? Na? Constant. Y is equal to mx plus c. Constant. Okay? Na? Fine. If you check here, this is the relations which are in. See here. Here I am writing the c is equal to 0. Right? C is equal to 0. When c is equal to 0, what you are getting? F is equal to 32. Means you are getting this value as positive. This is the positive value which I am getting here. This is 32. Correct? And what about if f is equal to 0, right? F is equal to 0, how much you will get the c value? Check it. F is equal to 0, c is equal to, you will get as how much? Minus 160 by 9. Correct enough? Okay. So this is the one intercept. Minus 160 by 9. Okay. So if you observe here, in this situation, the graph which I am getting is straight line. Why? Because the equation is a straight line equation. Correct? Is a straight line equation. Okay now? Is a straight line equation. Y is equal to mx plus c. This is the graph here. Then what is the slope of the graph? Slope of the graph. What is the slope? Slope I can say is from here, see here. This is the slope. Just compare here. M is the slope. M is the slope. Y by x. dy by dx. Do you know how to find the slope? Slope means sum. Slope is dy by dx. y2 minus y1 by x2 minus x1. That's it. y2 minus y1. y2 is 32. You can say directly from there 9 by 5 over answer. Okay. 0 by x2 minus x1 minus 160 by 9 minus 1. Okay. Minus 0. So you will get this one as, calculate this, you will get answer. Okay na? So, or simply we can write here. Simply we can write, we can compare here. This indicates the slope. Slope of the line is 9 by 5. Slope of the graph. Slope of the graph drawn between these F and C is a 9 by 5. 9 by 5 is the slope. Okay, na? In this way, I have to practice the graphs here. Okay, na? Some we may get some other graphs here. We can draw for everything. In the same way, we can draw the graph for all the scales here. Not only degrees Fahrenheit, we can draw for Kelvin and this also. Kelvin and degree Celsius also. Kelvin and degree Celsius also we can draw here. No problem. Kelvins and degree Celsius also we can draw. What is the relation? First you know it. C by 100 is equal. What is the relation between degree Celsius and Kelvin? Minus 273 by 100. Correct? Correct, na? Right? See, these two will get cancelled. So what I am writing here, C. 1 second. C is equal to K minus 273. So from here, K is equal to what can I write? C plus 273. Correct, na? What is this? See, Kelvins and degrees Celsius. Now I am taking the graph K on y-axis. Means Kelvins on y-axis and degrees Celsius on x-axis. In this way. Okay, na? Fine. If you take it here, what is my task is, it is like a straight line equation. Y is equal to mx plus c. Constant means, okay, na? Constant, careful here. Okay, constant, right? Now what you are saying here is, right, in this expression, from this expression, in the place of k, first write 0. Then how much you will get c value? Minus 273. Correct? Means if k is 0, c is equal to minus 273. Minus 273, c is minus 273. Here we will get minus 273 degrees Celsius. Correct? Now in the same way, just make c is equal to 0. Right? C is equal to 0 in this expression. What you will get? K is equal, you will get as 273. K you will get as 273. Correct? Now if you see here, c is equal to k, you are getting positive value only. Yeah. Yes, I am getting the positive value 273. So this is the graph. It's a straight line. Correct? In this way, okay, for two different scales, any two different scales, we can draw the graph. Easily we can draw it. Got it here? Easily we can draw it. Okay? Understood here? Fine. So in this way we can draw it easily. This is the way of making the graph here. Why I am telling you here is, it will be very useful for coming classes here in physics. Okay? Graph should be drawn. How to draw a graph? This is a method here. Because these expressions are in the form of a straight line equation. The equation which I am getting between these physical quantities, okay, is a straight line equation. When it is a straight line equation, I can say here this is a graph will be a straight line when it is drawn between these two. Got it here? So this is one method here. This is the way of drawing the graph. Any graphs you can draw. See here, just I have drawn a graph between this C and F. Correct? Using this relation here. Using this relation, I have drawn a graph between the C and F. Whereas here in the, and one more graph is drawn between the, what is this, K and C also here. And you can make a graph between these two also. Any two you can try it. Then we'll get an idea here. Okay? 1 second. This is a faulty thermometer. Y minus x by z minus x. This is the relation. See here, if you see this relation, see from nearly 4 days I am writing this relation here. In the same way you have to practice it. Okay? Just I have drawn a graph between C and F. Okay? Na? How to draw a graph between C and F. I have shown here how to draw it, right? And next I have practiced one more here between C and K also. Correct? So between this complete. Two graphs I have drawn here. Now you practice for different graphs here, different physical quantities. In sense, you can draw graph between C and R. Okay? You can draw graph between C and RK. Or you can draw a graph between, what is it, F and K. And you can draw a graph between F and R. Or you can draw a graph between F and RK. Like this, many graphs here. Not only this, the next you can draw a graph between K and R. And you can draw a graph between K and RK. And you can draw a graph between R and RK. Okay, na? In this way, if you practice these all graphs here, enough. That's what we have to do here. Understood? What I'll tell you the difference that different students will have here. Yeah. Okay, sir, explain this, understood. Okay, this one also sir explain, okay, understood. Simply they'll stop here. But some students will practice this all here. How to draw the graph between these? That students will be a topper. Will get extraordinary, good talent, development will be there. Why I'm explaining these concepts here is it will be helpful after joining here. That's why the reason is that how to draw a graph. Many students graphical problem they feel very hard but very easy. Got it here? Okay, na? So try to practice these all graphs here. Try to practice all the graphs. Method doesn't change, procedure doesn't change here. That's what the physics means. In physics, we'll have number of applications. Applications are app. I can say simply at app. Apps are infinite here. Correct? Applications are infinite, but the procedure doesn't change. Okay, now how to create the app? Creating the app is everyone knows here, but using the app will be different in different situations, right? Like this, in the same way. Means the procedure doesn't change in physics. Basic concept doesn't change in physics. Way of applying, try to understand. Do not by heart. If you by heart 100%, you will not get the marks here. Understood here? Okay? Try to practice number of problems here. We'll get easily we'll get everything. Okay, na? Fine. So this is the procedure of drawing the graph for different physical quantities. Got it here? Drawing the graph between for different physical quantities here. Understood? Okay, na? Fine. Okay, fine. We can do whatever we want here, right? So just practice that all the graphs. Once again, see the graphs here. It's better. Okay, fine. Practice all the graphs. After practicing only, just you will get the full clarity. Okay, na? For today enough here. Tomorrow we'll see some other topic, or we'll continue if any examples are there in this. Maybe if any examples are there, maybe some basic concepts are there here. Means we'll see that out in the next week. Right? Thank you. Take care. Bye.